Alright, welcome back Math 7. Today we are continuing the lesson chapter 8 circles. It's just continuation of chapter 8. One thing that you need to understand is even though we are calculating a lot today, so that we need a calculator, I still want you to have compass and ruler, because we are going to create questions, like class questions. It may not necessarily be from a textbook. Like improv way, we're gonna create some stuff. So again, if you don't have any of a compass, like what I mentioned, circular material, or any type of coin or anything that have a circular bottom, it is recommended, because you don't have to necessarily make the same example as I does. Like for example, when I do calculation of circumference, specifically using 3 centimeter radius, you don't have to. You may have a little bit bigger size, 6 centimeter. Still, you can do the calculation. That's what I want to point it out. Before we getting into the world of calculation of circumference, I like to do some definition check first. What is the term circumference? Circumference is basically a total distance. The total distance it's an outer edge distance around the circle. It uses the variable small case c or big case c. Doesn't matter which one you use for this one. And people generally measure it in different unit, like a linear measurement, and that can be like feet, inches, like the one that you use from imperial system like British and US, or it can be metric system like centimeter, meter, etc. There are quite a lot of measurement units that you will see in real life. So circumference work like this. I'm just gonna use this circular object. I personally do not know the radius and diameter of this object, so let's see. There you go. Where was my center? Okay, center is located over there, right below this point. This is a little disadvantage of using this because I cannot actually penetrate this center. So I gotta use a little bit of estimation skill. But in any case, circumference is a full distance. So imagine I start my running. It's like a track and field. Going around this track. Doesn't matter clockwise or counterclockwise. This example I'm specifically doing clockwise, but it really doesn't matter. Going around the outer edge and come back. This full traveled distance is known as circumference, known as big C. And you guys may know, I forgot what it's called, but it's a circular object type of linear measurement in gym. I know Mr. Romanek has it in St. Mary's School. There is a device where if you measure your circular distance like that, and then at the handle you see like, oh, that's a meter, 2 meters, something like that. You can actually determine the full distance too. This outer edge total distance is what we name it as circumference. So you can use your tape measure if it's an object. It may not be precise, but yeah, you can measure anything. Before we getting into the formula, you may need to remember, or if you haven't learned in grade 6, because I don't teach grade 6, you need to know about this term pi. In fact, Greek letter pi is what we or what you have heard it before. Pi is a certain ratio. This show, and you may know like 3.14 and go back and forth, blah blah blah, but I'm not talking about the number. I'm gonna talk about number later. Pi is basically the ratio of the circumference of a circle, in fact any circle, to its diameter. So this pi, if you don't mind, you can take out your calculator. I want you to take out your calculator. I'm gonna use the one that I have in a computer, like what you guys have been, familiar with in my lesson. If you locate pi and click enter, these are the number that you will have. I'm gonna put as much as I can. It's first of all not finishing number. It doesn't even have a pattern, but 3.141592653 and 97. Oh boy, dot dot dot. Pi is one of the number that you will learn in junior high for sure. That first of all, no pattern, and at the same time, it's not terminating. So we call this as irrational number in high school. Irrational number is basically, like the word suggests, rational means logical. It makes sense to you. Irrational means it's not logical. It doesn't make sense to you. I'm going with the LA perspective, but long story short, we don't know why whenever we compare the circumference to a diameter, we always get this 3.14 blah 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 whenever we have a perfect circle. So as you may notice, this pi, it's a Greek letter. Ancient time Greek philosophers and mathematicians, it was basically same job when it comes to those time. Philosophers, scientists, mathematicians, they don't have those fields specifically. When they study about the nature, when they think about nature, and certain groups, Plato and others, they were studying the circle. And long story short, they found that, whatever the circle size that we make, if we measure the total distance around the circle, which we name it as circumference, and if we divide it by the total distance of the diameter, which is the across distance, we always somehow get this magic number, 3.141596, blah, 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 and it doesn't have a pattern, and it does not terminate. It's infinitely going. But they named this as a special number, and they bestowed one of their alphabet, pi. It's like one of the very first variable. If you guys know like X, Y, Z, those kind of thing that we learned in a previous chapters. Yeah, imagine you're doing the same thing with pi. Except this is unchanging, constant, or variable, if you will. It's a number that we use. In junior high, it's crazy to use the whole number, right? So in junior high, we pick only important number we basically round up to 2 decimal place, and we basically use 3.14 instead of an actual value of pi in junior high. Well, at least in Math 7. If I tell you, when it comes to high school, you have to use the actual value pi. In fact, your calculator should have that value pi. The reason being is if you round it up, well, the answer is rounded up. You don't want to do that mistake in real life. But in junior high, like I said, at least in Math 7, 8, it should be okay. All right, so let's go through formulas first. Here's your formula to find out circumference. Circumference is equal to pi d. This, if I interpret it in detail, you will know that circumference is equal to pi, which is 3.14 times by diameter. This is a formula for each of them. But as you may notice, can you see it's a waste of the space and that it's unnecessarily long formula? So instead of writing in this way, mathematicians and scientists decide that C is equal to pi d, something like that. Some of you guys may say, Mr. Kim, what happens if we have radius given? Good question. Because diameter is 2r, right? So that means I can replace the letter D with this 2r. So some people may learn it or may heard it as, Mr. Kim, I thought 2 pi r is my circumference. This is also correct. It is fancy way of saying pi times 2 times r, because 2 and r is my diameter. Some people may wonder, Mr. Kim, why don't you write pi 2r? It's because numbers always go first. Letter later. This is a rule for numerical coefficient, if you guys remember that chapter. So how can I use this formula into a question? Let's do some example. I'm gonna do some classic example. Why not? I'm gonna draw this circle again. If you have any type of other circular object, feel free. There you go. The center is located over there. Easy example first. Let's say I'm actually kind of curious. What is my diameter for that circle? 1, 2, 3, 4.4. It turned out that my small circle that I created have 4.4 centimeter as diameter. Your first step, I want you to list every clue that you have in each scenario. Right now I have diameters given 4.4 centimeter. Step number 2, formula. I want you to write down and copy the formula. C is equal to pi d. Step number 3, substitute values. So what I mean by that is C is equal to, instead of pi now, why don't we using 3.14? Then we punch the rest of the number, 4.4 centimeter. And now, and by the way, I'm gonna give it a little advice in here. Keep units. Although I didn't put units in here, but Circle is a measurement question, so you have to use whatever the method that you use for measurement or what the question says. So now take out your calculator. I want you to put 3.14 multiplied by 4.4. Then you will have 13.816 centimeter as your final answer. This is a situation where you have diameters given. Now, what if radius is given? Now, here's the thing. Radius is given as 2.2 centimeter. I'm going to use the same scenario, if you will. Now, imagine diameter is not given, radius is given. So we're going to copy what we have given first. Radius is 2.2 centimeter. That's my first step. Now, my second step. Write down the formula that we know. C is equal to pi d. But at this point, you may notice that diameter is basically doubling the r, so I can substitute this value in, and that's like pi times 2 times r, which, or people know it as 2 pi r. Order doesn't matter, fortunately. If you express, I prefer this because numbers always go to the front. It's kind of like alphabetical order in the world of math. You can think it in that way. Always natural number or countable number go to the front, or fraction too if you go to high school. So now my step number 3, punch the number in. C is equal to pi was 3.14 times by 2 times 2.2 centimeter. As you may notice, like what I emphasized, it is important to include units because it is a measurement problem. So now 3.14 times by 2 times by 2.2 is equal to 13.816 centimeter. So you have basically same answer, which doesn't surprise you. It's a circumference of a same circle, so you should basically follow that. Now let's do one textbook question that is not necessarily asking you to draw a circle and then find out. It is more scenario question. It is available on textbook page 276. I'm going to read the question. The carousel is a popular children's amusement park ride. The radius of the carousel is 6.1 meter. Now, I know that it's not 6.1 meter, but as a scale, I'm going to draw a quick example circle. Center is over there. Now, this is carousel. This is a popular children's amusement park ride. If you don't know, this is like merry-go-round, something like that. The only clue that is given is basically our radius. So from center to any place in outer edge distance, that's my radius, and that is given as 6.1 meter. Of course, it's not 6.1 meter on a piece of paper, but you got the idea. It's a scale situation. Question letter A, I guess. Estimate the circumference of the carousel. So, although I don't ask you about estimate, I'm gonna teach you how to do estimate. So first thing first, step is exactly same. Radius is equal to 6.1 meter. We know that. Now, estimating skill, it's like without calculator. Step 2, if you guys remember, it's equal to pi d, right? But you know that diameter is 2 times r, so you can put 2 pi r, something like that. This is what we did before. Now, next step. When you do your estimation, just use a rounded number. I know that pi is 3.14 and r is 6.1 meter, right? But if you imagine you're using your brains without any calculator, you may have hard time dealing with these two's multiplication for actual answer. So here's what we do. Instead of 3.14, that's around 3. Instead of r, 6.1, that's around 6 meter. So basically it's 2 times 3 times 6. So 3 times 2, that's 6. 6 times 6, that is around 36 meter. Is this an actual answer? No, it's not. But it's estimated circumference. Whenever you see estimating question, that's what you can do. B, what is the circumference of the carousel? So now it is asking a specific number. Then you have to use calculator. I know it's 2 pi r, so that means 2 times 3.14 times r, 6.1 meter. Then C answer should come out, which is, and I'm gonna punch the number in the calculator, 2 times 3.114 times by 6.1, that is equal to 38.308 meter. But the question says, what is the circumference of the carousel to the nearest tenth? That means we need to round it up. The place that we need to round it up is basically all the way to the first decimal place if it says nearest tenth. So that means 38.3 meter as your final answer. So that is what you can do. The question C is asking that Andrew sits on a horse on the inside of the carousel. The horse is 3.2 meter from the center. How far does Andrew travel in one rotation of the carousel? So we're kind of use a specific point, not literally lying on the circumference, but 3.2, let's say it's about a little bit halfway to pass over there. Imagine this is where Andrew's sit is, and that is 3.2 meter. As you may know, this is also radius, but I'm gonna call it R2 specifically for this situation. And the question is asking, how much distance does Andrew going around? As you may notice, it's very ugly circle, but I kind of make it assuming that it is going counterclockwise. Even if it go clockwise, shouldn't really matter. So the question is asking now circumference that Andrew go through. Formula doesn't change. It's pi d, which is, in our case, we know the radius, so 2 pi r. Except this r is different radius. So 2 first, that's 2, times by pi, 3.14 times by r, which is 3.2 meter. And you can basically punch the number in. I'm gonna put CA, something like that. 2 times 3.14 times 3.2 is equal to 20.096 meter. And it says, as exactly same as B, round it up to the 10th place, which means I have to include the first decimal place, and you know that 9 is already bigger, so we need to round it up as 20.1 meter, and that is my final answer. That is a lesson about circumference, ladies and gentlemen. Now, your to-do list is basically, this is more than yesterday or last class for sure. because it is quite important. I want you to work on homework page 278, 4, 6, 8, 10, and 11, 13 of page 279. Please do estimation if you need so, or actual calculation if the question says so. So have that in your mind.